And if you'd be so kind as to write the word direct variation. And because I know that some of you like to decorate your notes and make it look awfully spilly, I'm going to give you what the main thing is that you have to have in your notes that you can see, and then we'll work around that. Your direct variation, this is what you need to write in your notes. The letter Y equals K, and then X. What color shall we fill that in?
Pink.
These letters mean absolutely nothing to you, do they not? Do we have that? Y equals, I missed this one, didn't I? Okay. Now, what does that mean? Anybody? Well, first of all, let's just say this. Direct variation is really nothing more than the same thing as being proportional. Which, if you break it down to its simplest form here, just means as one thing goes up, so does the other. And really, let me give you the example, and then maybe it'll make more or less sense. I got a 50-50 shot at that. When you get older and wait, how many of you already have a job? Anybody have a job in here?
So lemonade stand.
Liv, what's your job?
I live for my grandparents.
Okay, do they just throw money at you, or do you get a certain amount per hour? Just
certain amount.
let's pretend. Let's pretend you know what that is an hour. How much do you make an hour?
Maybe $2.
Let's go with somebody who's not in the poverty range. That's for how much an hour?
I don't get an hour.
Somebody give me an hourly wage here. Caleb Fisher.
$8.
Okay, let's say Caleb is working. Caleb makes $8 an hour. Okay. You can show that as a direct variation because here is the equation that we would use for that. The letter Y, which would be this, equals $8 times X. Where X is what? The number of hours. What do you suppose Y is? Y would be how much cash. Okay. And you could make a little table about this. Okay. If Caleb works 0 hours, Caleb makes $0. Caleb works 1 hour, he makes $8. If he works 5 hours, he is making $40. Okay. You know this is direct variation because as the hours he works goes up, so does his pay. Now, there are things where that's not always the case, where the more you do, the other thing goes down. For example, if I'm driving from here to Morris, which is about, whatever, 20 miles away, if I'm talking about the time it takes me to get there, as my speed goes up, the time it takes me to get there goes down. That's not direct variation because as one goes up, the other one goes down. But this, ladies and gentlemen, is direct variation. And direct variation has this little guy right here. See this letter K? That letter K is what we call the constant of variation. It is what I multiply x by every time to get my y. It is a constant. And when you have direct variation, two things have to be true. Everybody know what they are? They would be the same two things that are true when we talked about being proportional. Remember what two things have to be true? If you are graphing direct variation, say I was graphing Caleb's monetary thing here, remember? Here are the hours he worked, and here's the money he made. He works 0 hours, he makes $0. He works 1 hour, he makes $8. He works 2 hours, he makes $16. So I get this nice little line right here. What two things have to be true for something to be direct variation? Number one, it has to go through the origin. When one is 0, so is the other. And number two, anybody? The graph has to be a straight line. Because if this graph wasn't a straight line, and I made it all whirly-spurvy, you know, my line went like this. Well, if Caleb worked 2 hours, he's only going to make like $8. But then if he works 2.5 hours, he's going to work 9. If he works 3 hours, he's going to work like 15. It would not make sense because he'd be getting a different pay rate all the time. So it has to be a straight line. And then with that, we also have to define this. The x number is what we call the input number, and it is called the independent number. And the y number, guess what it's called? Output, and it is also this is independent, this one is dependent. Why is it dependent? Because what you get for y depends on what you put in for x. They spell dependent right? Who's my spellers? Are they all E's? Are they all E's? Somebody. Yes, they are. So far, so good. Some of this, it doesn't make a whole lot of sense until you actually look at some problems there. So do me a favor. Look at page 467. But this, by the way, this is the big thing right here. Make sure you know this is the, what do we call this? The variation equation. Let me see what the book calls it so you can label it appropriately. It doesn't label it, it just says the direct variation. Huh. I don't know that. Wait, are you with me on page 465? Or 467, sorry. Why is that? Now, look at practice letter A. Is that Trini?
Yeah.
How many of you know Trini? Anybody besides this? Trini drew some equilateral triangles and measured their side lengths. She decided that the perimeter of an equilateral triangle varies directly with its side length. Write an equation for the relation and identify the constant of proportionality. Now that's a lot of highfalutin hubbub for something that's pretty simple here. Let me throw you the table. What was the table? Look like this. How many different pieces was it? Looks like 5. Is that 5? This was X, was this Y? And the number, oh, S and P. Now, ladies and gentlemen, S and P, really, you can just think of them as being X and Y's. It's kind of the same thing, except why do you suppose they used S and P? So that they can keep track of what they're talking about. This is the side, this is the perimeter. And what was it? It was 2, 6, 3, 9, 4, 12. 2, 6, 3, 9, 4, 12, and 721. Now, they asked you for two things. What they asked you for? Write an equation. All right. So here is your equation. Remember, your equation has to fit this pattern. Y equals kx. So the question you ask yourself, Aaron Murray, is what do I multiply x by to get y? So what did I multiply x by to get y? 3. So this is going to be a 3. Now that has to be true for all of them, otherwise it is not a directly proportional direct variation thing. Did I multiply this by 3? Yes. Do I multiply this by 3? Yes. Do I multiply this by 3? So yay, this is direct variation. It is also proportional. Now the question of the day is, Brian Diedrich, what is my constant of proportionality in this equation? Wait, before you answer, let's go back. What number would be my constant of proportionality? Right? Wait, let me go back. Constant proportionality falls right in front of the x. What is my constant of proportionality? Just take a guess. It's a number between 2 and 4.
3.
3. The number in front of the x, ladies and gentlemen, is the constant of proportionality. It is the thing that I keep multiplying everything by to get the other thing. I don't overthink this, it's not that hard. Look at letter B. How much time do we have left? Oh, this is crazy. Stop. The relationship between Sergio Garcia's age and Fernando's age is illustrated in the graph. Are their ages proportional? Or is it direct variation? Yes or no? Lauren Ulrich?
No,
Why not?
because when one is 0, the other one has to be 0.
Yes. When one is 0, the other has to be 0, and that is not the case. They are not proportional. It is not direct variation. There is no constant of proportionality. There is no constant of variation. There is no direct variation constant of whatever. Oh, look how quick that was. Look at letter C. Maybe I should have somebody read this. Who wants to read letter C? Chase, thank you. Wait, you don't have your glasses on. You had your glasses on yesterday, and you don't have them on for math class? Oh, me too. So what kind are yours? They're like bluely tinted? Go ahead, Chase. I'm done.
The weight of water in the trough is directly proportional to the quantity of water in the trough. The 20 gallons of water weigh 166 pounds. What is the weight of 30 gallons of water? Find the constant of proportionality in pounds per gallon. Then write an equation for the relationship between P per pounds and P per gallons.
Gee whiz, is that crazy? How do we figure that out? So we've got an equation. Now the question you have, we're talking about, ladies and gentlemen, as you think about this, we're talking about pounds and gallons. Which one would be the input number? Which one would be the output number? In other words, if you knew one, do you know the number of pounds to find how many gallons, or do you know the number of gallons and then you figure out the number of pounds? Which one would make sense to be? Because we're trying to think about which one would be our x number, which one would be our y number, which one would we put in the first column, and then figure out the one in the second column. Which would be which? Madison says.
P is x, G.
So you would find the number. So if I said something is 3 pounds, you figure out how many gallons that is. That's the question on the table. Which one would you use as the x? Which one is the input number? Which one are you using to find the other one? Do you use pounds to find gallons, or do you use gallons to find out how many pounds something is? That's the question of the day, Olivia.
Gallons per pound.
Right. If you know how many gallons something is, you find out how many pounds it is. Which it told me what? How many gallons was how many pounds? 20 gallons was how many pounds? 166. So my X is my gallons, this is my pounds. So my equation is P equals some constant. I need to figure out what it is I multiply this by to get how many gallons. What am I multiplying gallons by to find pounds, and how would I figure that out? Anybody? Zachary?
Divide 20 by 60.
And what do you get?
Doing
8
points.
is 160. How many times does 20 go into 60? 8.3. Your constant of proportionality is 8.3. You multiply anything that goes in this column gets multiplied by 8.3 to figure out what it goes in the other column. Right? Did I do that right? So the question they asked you was, if you had 30 gallons of water, how many pounds would that be? You take 8.3 times 30, 0, 9, 24, 249 pounds. Oh boy. Look at that.